So this video is going to go over the beginning parts of limiting reagent, limiting reactant. So I'm going to go through a practice problem or two just for you to get the idea of how to do these calculations, including what we call a BCA table. So limiting reagent or limiting reactant are interchangeable in the world of chemistry. And what I've taught you before with stoichiometry, it's all about a recipe. It's all about a recipe. So again, I keep coming back to my blonde brownies, and I have a certain recipe that I need so much flour, so much eggs, brown sugar, butter, okay? But when I go to my pantry, I have certain ingredients. And so what limiting reagent or limiting reactant has to do with is how many brownies can I make by what I've given in the problem. So I have to refer back to my recipe to see what combinations, what proportions do I have, and then from there do a calculation. So that's where we're going with this. So some definitions or things that you need to be aware of. Limiting reagent and limiting reactant. It's a reactant which limits the amount of product that can be produced. So it's exactly what it sounds like. And if you're given an amount of both reactants, you need to calculate which one makes the least amount of product. So there's many different ways you could approach these kinds of problems. There's going to be one way we kind of teach you. But if you find other ways out there, go for it. Okay, whatever seems to work is going to be fine. So we have this reaction. Hydrogen gas plus oxygen gas produces water. So if I go to my pantry and I have 4 moles of hydrogen and 3 moles of oxygen, how much water could I make? So we are going to continue to do what we call BCA tables. They stand for before, change, and after. Okay, so after a couple of these, we're just going to use B, C, and A. Okay, so just make it a table. It's just a way to kind of organize the information so that we could find it when we're asked certain questions. So the first thing I want you to try to do is to look at the recipe and see that I have a 2-to-1 relationship between the hydrogen and the oxygen. That means I need twice the amount of hydrogen as I do oxygen. So what I want you to do is look at what's given in the problem and see if you can rationalize, okay, which one is going to be limiting and which one is going to be what we call excess. So oxygen, I need, for every 1 mole, I need twice the amount of hydrogen. So if I look here, I see I have 3 moles of oxygen. If I need twice that, I need 6 moles of hydrogen, and I don't have that. So if I can't see it, I'm going to do what I call a mole-to-mole type problems. So I'm going to take 4 moles of hydrogen, and I'm going to say, okay, how many moles of oxygen do I need to react with it? So I'm just going to do a mole-to-mole. So we're just repurposing things that we already have learned. So 2 moles of hydrogen for every 1 mole of oxygen. So set up your proportion and cross multiply. I end up with, I only have 2 moles of oxygen reacting. Okay, because I had 4 moles of hydrogen, that would mean I only need 2 moles of oxygen to react with that. So that's really going to be how much is changing with the oxygens. Please understand, change on this side is going to be negative and this side is going to be positive because we are starting with no product. And this is not math class. We cannot subtract from 0. We cannot subtract from 0. So the change in the oxygen is going to be the mole-to-mole I just calculated. So that's going to be 2 moles that is reacting with the hydrogen. The hydrogen is going to completely be used up, So that's going to be 4 moles is going to be the change. So when I subtract those two, this is always going to go down to 0. So whatever is my limiting, LR is going to be our abbreviation for limiting reagent or limiting reactant. That is always going to go down to 0. So one of the reactants is going to go down to 0, and one you're going to have what we call excess. So I have 1 mole of excess oxygen. And then I need to calculate, well, my water, how much water do I make? Well, my water is going to depend on my limiting reagent, okay? That's going to drive how many brownies do I make, okay? So again, how much water can I make from that? So hydrogen, what I could do is I could take, okay, for every 4 moles of hydrogen, how many moles of water can I make? Now, some of you are going to be able to see this relationship pretty quickly, but realize that it's a 2-to-2 relationship. So however many moles of my limiting of my hydrogen is going to be the same as my moles of water. Okay, so that's going to be 4 moles of water that I'm going to produce. Okay, so it just so happens that they're both 2 to 2. That's why that is a 4. That isn't a magical way these problems are going to always go. So that means I make 4 moles of water as my product. Okay, so that's my ending. So again, we could draw some of these molecules, but because our math problems are not going to be always nice for the drawing, we're going to use these BCA tables to essentially organize our information and find out what's our limiting, what's in excess, and how much do I make in the product. All right, so I would like you to try, so copy down this relationship. I have nitrogen plus hydrogen goes to 2 ammonias. I am going to my pantry and I have 2 moles of nitrogen and I have 5 moles of hydrogen. So that's going to be in our before. And we are always going to assume that we are starting with no product. We are starting with no product. So I want you to pause this video and see if you could fill in this table. And then in a moment, I will go through how to solve this problem. Okay, so please pause the video. Okay, so I see that I have a 1 to 3 relationship between the nitrogen and the hydrogen, 1 to 3. So I have 2 moles of nitrogen, 2 moles of nitrogen. So what does that mean in terms of my hydrogen? Well, if I have 2 moles, I would need 3 times that. I would need 6 moles of the hydrogen, and I don't have that. So my guess is hydrogen is my limiting. Hydrogen is my limiting reagent. So I'm going to see if that is the case. So I am going to do, I'm going to take 2 moles of nitrogen, and I'm going to see how many moles of hydrogen I need to react with it. So I have 1 mole of nitrogen to 3 moles of hydrogen. Okay, so these are all just mole to mole problems, mole to mole problems. So 2 times 3, so that means I need a total of 6 moles of my hydrogen to react with all of that nitrogen. So I don't have that. So this is definitely going to be my limiting reagent, and nitrogen is going to be my excess. This is a video I'm recording. There is Mr. Rousey. Everybody say hi to Mr. Rousey. Okay, so I have confirmed that hydrogen is my limiting. So now I need to know how much of the nitrogen actually is required. So I'm going to take my 5 moles of hydrogen and I'm going to figure out how many moles of nitrogen are going to react. So I have 3 moles of hydrogen for every 1 mole of nitrogen. Okay. So cross multiplying, I end up with about 1.7 moles of nitrogen. So that is how much reacts with the 5 moles of hydrogen. Okay, so this is going to be my change. This is how much the nitrogen is changing. So again, change is always going to be negative on the side that has starting material and positive on the side that's starting at 0. And that will make a little bit more sense as we do more problems. So the change for the nitrogen is going to be 1.7. 1.7. So when I subtract those two, I get 0.3 moles. That's going to be how much is in excess. This is going to go down to exactly 0 because the limiting is always going to go down to 0. So that's 0. And then my ammonia, I need to calculate. Okay. I have to go back to, again, my limiting. I can't look at my nitrogen because I have extra nitrogen. So I must always go with what's limiting me from my pantry. So hydrogen is going to be my limiting. So I'm going to do a mole to mole of hydrogen and ammonia. So I have 5 moles of hydrogen, and I want to know how many moles of ammonia I can make. So I have to go back to, again, theme is always going to be balanced chemical equation. So I have 3 moles of hydrogen to 2 moles of ammonia. So 3 moles of hydrogen to 2 moles of ammonia. So 5 times 2 is 10, divided by 3 is going to give me approximately 3.3 moles of ammonia that I'm going to produce. So that's going to be what's my change because I start at 0. So that's going to be how many moles of ammonia I make, NH3. So with these types of problems, you're going to have something in excess, something limiting, and you're going to make so much product. The only difference with the next couple calculations you're going to see is we're going to change things to grams. That's the only thing that you're going to see differently. But BCA tables always must be done in moles, okay? And it's a good way to kind of organize who's limiting, who's in excess, and you don't lose the numbers as you do these calculations, okay? So that is the end of that video.